A new accelerometer was used. The original accelerometer in the Mark I experiment was not as accurate as I would have preferred. In its place, I am now using an Adafruit BNO 055 IMU connected to the I2C port of the Nano. The new IMU has auto calibration and also converts the G forces to meters per second squared, which makes it generating the data easier as well, because it also has a feature to do linear acceleration, which removes the gravitational acceleration from the acceleration data. That way, so like when it's falling at, say, the rate of gravity, instead of reading 0, it would read 9.8 meters per second. So that kind of thing. So then when I'm dropping the north-south magnet, acceleration of 9.8 would have been okay. It conforms to gravity, but it's surpassing that, showing it's surpassing the acceleration rate due to just gravity. And then here's more line charts with error bars and stuff. You can see in these were also hand dropped, and the drop distance was around 215 centimeters for the hand dropped items, because I was able to basically place the back of it up against the ceiling and then drop it down on a memory foam mattress topper to cushion the blow at the bottom. But if we go by just the purple one on the bottom, we can see that one is a little over 11.75 meters per second squared. These are taking the mean of the 15 trials that I conducted per each magnet object experiment in the Mark V experiments. So yeah, that's the mean and the error bars for the variation and stuff. To note, the 45-degree taper and 55-degree taper proved the most successful and had the highest acceleration rates versus 65 and 75-degree taper variants. As you can see in this one, the orange one stops at, see, it's a little over 11.5, and then this is 11.5. So difference between Mark I and Mark V, with the most successful in Mark V was an acceleration gain of around 0.75 meters per second squared. Definitely you want to have the magnetic field is most fully encompassing your free fall object as possible to decrease inertia on your object as much as possible. Okay, now I got the Mark V-A and Mark VIII free fall object experiments, which I've done later since those earlier experiments. The Mark V-A and VIII experiments are the first to use a computer-controlled release mechanism instead of dropping the objects by hand. When I printed out the back piece of the object shell, I have a little hole in the top, and I feed a little small fishing line string through that, tie some overhand knots on the inside so when you pull it, it doesn't pull out. And then I use 2 solenoid coils. I turn them on. I stick the fishing line between them and then push. I have it so you can push the right solenoid coil up to it. And then when it gets close enough, the magnets lock together and it pretty much keeps the fishing line from slipping. This image on the right is a breadboard with the red button is to turn on the solenoid coils to lock. And we got an Arduino Nano on the breadboard that's connected to a driver board, which gives the power to the solenoid coils. And the green button initiates the drop. Okay, I might have already just covered some of this. For the experimental methodology was the fishing line with the attached freefall object is inserted between the two attractively oriented solenoid coils controlled by an Arduino Nano. The red button on the breadboard is pressed to turn on the two solenoids, and then I physically push them together where they then trap the piece of fishing line. Using serial Bluetooth terminal on my cell phone, I send a command to the Arduino Nano inside the freefall object to start recording the accelerometer data and gyroscopic data using the Bosch's BNO055 IMU available from Adafruit, running in IMU plus mode, which means that it disregards magnetometer data and only fuses together accelerometer and gyroscopic data. And I have the output of the vector linear acceleration mode, which again, instead of like say if the object was in perfect free fall, I would report 0 meters per second squared. Well, with the vector linear accelerometer, it will report 9.8 meters per second squared. Which I find to be more handy for understanding how the object is accelerating at a rate greater than gravity. The green button on the breadboard is then pressed to deactivate the two solenoids, dropping the object. I then use the serial Bluetooth terminal program to transfer the recorded data to my cell phone for future analysis. Okay, I guess the Mark 5A freefall object experiment, I only conducted experiments with a non-magnetic control, the north-south, north-south, and the south-north, south-north. Basically, it was because the shell is so small and the foam is so small. Because when trying to force together two repulsively coupled magnets, like a north-south to a south-north, they want to fight each other. They do not want to go together. And I have found that I needed like at least a 3-inch bolt with I would have a 3-inch bolt going through the bottom magnet. Then I would have a piece of MDF with a slot in it that the bolt would slide through the slot. And that way I could put my feet down on the MDF board, and then I could push down with my arms to get the magnet down just enough to start screwing on the nut, and then I could create the repulsively coupled magnets. But a 3-inch bolt is too big for the Mark V freefall object. So that's why the two repulsively coupled configurations weren't done in the Mark V object. And as you can see here, the error bars, from the control, they look pretty tight. The sort of south-north, south-north are a little higher. I don't know, they look similar to the north-south, north-south ones, the error bars. But obviously, these are being dropped by my. I originally created a guide wire system using 2x4s, and it was going to ride on the guide wire system, and that was a debacle. It didn't work at all. There was way too much friction with interacting with the guide wires, but it was useful to repurpose that device to then computer control the release of the freefall objects. That said, that device shrinks the distance that the object is falling somewhat, because I only have 8-foot ceilings, and so I had to decrease it by about 20 centimeters from above the ground. So it decreased it a little, and I tend to think that the curve at the end is due to the way the shape of the memory foam mattress topper that sit on the bottom. I had like two pieces of foam sticking up in the air on the front and back to try to help the free fall object from not falling out outside of the foam, kind of catching that. I assume it hit air resistance due to that, and that's why the north-south starts to slow down at the last three frames there. The Mark 8 free fall object experiments. Well, I was hoping to induce more wobbling in the front of the magnet, because normally a static permanent magnet creates a static field, and if there's a charged particle in that field and it's not moving, to my understanding anyway, then it just, the field doesn't have any effect on it. But if you have a dynamic magnetic field, then that will affect the charged particle. So I was hoping to get a decent amount of movement with the Mark 8 experiments to create a more dynamic environment and hopefully increase its free fall speed. Honestly, in the end, it didn't dish out anything with any real value. Its free fall speeds were no greater than the Mark 5A. What I did do is I offset the magnet object from center 5, 10, and 15 millimeters. That was in 3 trials. And then in the other 3 trials, I tilted it 5, 10, and 15 degrees inside the plastic shell in the foam shell. But yeah, you can see they average around 10.25. So I'm getting a little close to 10.5, maybe 10.4. So nothing to write home about. That didn't seem to be, and again, 195 centimeters above the ground. But yeah, it didn't seem to be worth replicating. Okay, and now taking a lateral step, or I don't know if a step back, a step to a different direction. Not quite. It's still very applicable. The alien reproduction vehicle. One highly controversial UFO in the world of ufology is the alien reproduction vehicle, as leaked by Brad Sorensen and Mark McCandlish and Leonardo Sanderson and Gordon Novell. While its existence has never been proven, its leak first occurred in 1988, which is about a decade before Boyd Bushman conducted his magnet freefall experiments. The ARV was reported to have what looked like a solenoid coil around the circumference of the craft. That's the object at the mid-height where the slanted panels stop and then a curved and then the circular top starts. It's that coil that's around the center circular part. Solenoid coils have a north and south pole, just like the permanent magnets I used in my experiments, although it is far more likely they would have used a pulsed DC current through that coil to maintain a consistent high energy, high frequency magnetic field that would affect inertia from interacting with the craft. Like I said, I use static permanent magnets. I tried to make them more dynamic by wobbling with the offset and tilted magnets. But an electromagnet, just by pulsing currents through it, will make a much more dynamic magnetic field. Okay, so it's quite possible that UFOs use solenoid coils for inertial mass reduction of their craft, as well as shielding the craft from cosmic rays or the solar wind, because magnetic fields can alter charged particles, and a lot of the solar wind and cosmic rays are charged particles. It is possible that inertial mass reduction takes place to such an extent that the solenoid coil enables faster than light propulsion. Okay, and here's hypothesis I've come up with on the cause of inertial mass. The Casimir effect was first predicted in 1948 to arise from quantum fluctuations, the generation of virtual particles in the vacuum, and was first experimentally proven in only 1997, not that long ago in the grand scheme of things. The Casimir effect is an extremely short-range effect, only imparting a significant force at distances less than 1 micrometer. When two uncharged conductive plates are placed in a vacuum at distances apart of less than 1 micrometer, the Casimir effect imparts less of a force pushing the plates outward than it does pushing the plates inward, resulting in the conductive plates being pushed together. I hypothesize that when an object is accelerating, an asymmetrical Casimir force is experienced by the object, as one side of the object is receding from the force responsible for the Casimir effect, and the other side is advancing on the force. I believe the Casimir effect is at least partially responsible for the generation of inertia. Hypothesis on the cause of the Casimir effect. As was just established, the Casimir effect arises from quantum fluctuations, the generation of virtual particles in the vacuum. But what exactly is happening? Virtual particles pop into existence as particle-antiparticle pairs, like the electron and the positron pairs, possibly in the bound state known as positronium. That is such an example. They then annihilate, creating short-lived virtual gamma-ray photons. I believe it is these short-lived, short-range virtual gamma-ray photons that are the basis of the Casimir effect and responsible for the force behind the Casimir effect. It is established that magnetic fields act on charged particles such as electrons and positrons, but not on uncharged particles such as photons. I hypothesize that the Casimir effect can be controlled with electromagnetic fields. Such fields need to act on the virtual electron-positron pairs while they are still charged particles before they annihilate and become uncharged photons. Electromagnetic fields can alter the axis of spin of electrons and positrons, causing their axis of spin to align with the field lines of the magnetic field. When the virtual particle electron-positron pairs annihilate, the vectors of the two virtual gamma-ray photons will be aligned with the field lines of the magnetic field. If the field lines of the magnetic field mostly do not intersect with the accelerating object, then the virtual gamma-ray photons will mostly not collide with that object and not impart their energy. I believe this is to be the basis for the results seen with the north-south magnet objects. Controlling and engineering the Casimir effect continued. Stronger magnetic fields have a greater ability to alter the axis of spin of electrons and positrons and align them with the magnetic field lines than weaker electromagnetic fields. Further, the greater an object's acceleration, the stronger the magnetic field needs to be to alter the virtual particle pairs farther away from the object that is accelerating. I hypothesize that pulsed DC electromagnetic fields have a greater ability to engineer the Casimir effect than static fields. In my magnet freefall experiments, the fields are not entirely static, even though I'm using permanent magnets, as the magnet is in motion and wobbling at the front, and therefore applies somewhat of a dynamic field on any virtual electrons and positrons. I hypothesize that the high-frequency pulsed electromagnetic fields have a greater ability to engineer the Casimir effect than low-frequency pulsed fields as well, as it increases the likelihood of altering the axis of spin of the electron-positron pair before it annihilates. Now, okay, here's the here's the Hail Mary. Here's the maybe reaching too far. I don't know, but free energy by controlling and engineering the Casimir effect. So far, we have discussed engineering the Casimir effect in order to prevent the virtual gamma ray photons from colliding with an object using a magnetic field for the purposes of inertial mass reduction. Now we'll discuss engineering the Casimir effect to purposely cause one of the two virtual gamma ray photons from each annihilation to collide with a turbine blade whose apparatus is attached to an alternator to generate electricity. The Halbach array. The Halbach array is a configuration of permanent magnets. Now you could, just for the purposes of explanation, okay, you have an up arrow. That means, for this example, let's just say that means that the North Pole is at the top. So you have a North Pole of a magnetic field up at the top. Then you have the left, and then you have down, and then you have right, and then you have up. And all this time, you're generating the North Pole of the magnetic field with this specific up, left, down, right, up, left, down, right configuration of permanent magnets. So you end up with a very strong magnetic field on one side and a very low power magnetic field on the other side. I guess I kind of just explained that. If you, so in that particular one, that particular configuration, up, left, down, right, that creates the magnetic field on top. If the permanent magnets are arranged with a field where it's left, up, then right, and then down, then the field will be strong on the bottom. And of course, the polarity depends on if you're, well, these are permanent magnets. Of course, you could, instead of choosing to do it with the North Pole on top, you could flip that around, and wherever side the arrow's on, you could make that the South Pole of the magnet. So you could change whether you have a strong South Pole magnetic field or a strong North Pole magnetic field. But yes, creating such a field with that repeating pattern creates a strong magnetic field on one side and a very weak field on the other. A Halbach array is traditionally made with permanent magnets, but for our purposes, electromagnets are needed because permanent magnets are largely static fields and electromagnets are largely dynamic fields. Why a Halbach array? With high-frequency pulse DC electromagnetic coils in place of the permanent magnets in the Halbach array, one side of the array will have a much greater ability to alter the axis of spin of the virtual electron-positron pairs than the other side that has virtually no field. As a result, on one side of the Halbach array, the virtual electron-positron pairs annihilate with their axis of spin perpendicular to the Halbach array, with one virtual gamma ray photon flying away and disappearing back into the vacuum, while the other will fly into the Halbach array, imparting its energy and momentum. On the other side of the Halbach array, the virtual electron-positron pairs axes of spin will all be random due to the marginal magnetic field, resulting in the virtual photons flying equally in all directions. One side will have a traditional random Casimir effect force imparting energy to it, while the other will have a much more polarized Casimir effect force importing a greater amount of energy and momentum into it. This imbalance of force will result in a rotation if built into a turbine. And then the turbine can be attached to an alternator to rotate the alternator and generate electricity. Now back to the free fall experiments. Where to go from here? The taller the fully automated drop device, taller fully automated drop device Mark II. In the time after I completed this presentation and before giving it tonight, I have upgraded the drop device. Now when the green button is pressed, A series of actions takes place. Master Arduino attached to that green button communicates with the Arduino Nano and the freefall object, first telling the IMU in that freefall object to start recording. A timer starts in the master Arduino, and the master Arduino releases the freefall object. When the object passes through an IR beam at the bottom of the drop device, the IMU will stop recording and the timer will stop. The data is then sent over Bluetooth and saved as a CSV spreadsheet file on a micro SD card connected to the master Arduino for later analysis. Continued. I intend to add camera recording functionality to videotape the free falls. I'll need to write some Arduino code for the master Arduino Nano to communicate via Bluetooth with a smartphone to initiate recording when the green button is pressed and deactivate it when the bottom IR beam is broken. I actually got the camera code to work, but now I had to use an Arduino library called Nimble NIM-BLE for Bluetooth -Arduino for the master Arduino because it needs to pair when connecting with a smartphone. And I can't get it working correctly with the Arduino BLE library that's on the Nano in the freefall object. I'm sure I'll get it squared away, and if not, I guess I'll just have to keep initiating the recordings with the camera manually while everything else is automated. But I'm hoping that I'll be able to fix this problem. The next stage of the drop mechanism is to increase its height for use outdoors. The drop device will be fully automated. A single button press will start the series of trials. A stepper motor attached to the freefall object with fishing line will wind the freefall object back to the top, shutting off when the freefall object blocks the top IR beam. Then the two solenoid coils will activate, holding the fishing line and the freefall object in place. The stepper motor will then move forward a little bit, and thanks to another stepper motor, and then it will unwind the fishing line. So when the freefall object falls, it doesn't get caught pulling on any taut fishing line. All the fishing line attached to it will be completely loose. The object is then released, breaking the bottom IR beam, and the process repeats for the number of trials desired. I'm debating at this time whether to try a double extension ladder where I have my current 7.5-foot device and use another two 2x4s to make it 14 feet tall, or if I want to try triple and make it 20 feet tall. I'm still unsure of doing that, but I think it could really help push this along for people who are skeptical with line charts and all this other presentation, and they just want video evidence. They say a picture is worth 1,000 words. How many words is a video worth? After giving it some thought, I decided the taller, fully automated drop device will be a dual drop device. Oh, this too. I forgot about this for a second. A physics paper with line charts and tables is all well and good for the average person, perhaps even those running physics journals, that it's not enough. When extraordinary claims are being made, many will want extraordinary evidence. I believe video evidence is more likely to convince skeptics than just about any other evidence. The dual drop device will have the north-south freefall object on one side and a control object made up of non-magnetic stainless steel 316 fender washers and the same size object on the other side. With the camera recording and with higher drop distance and computer-controlled simultaneous release, I'm hoping for clear video evidence that the north-south object reaches the ground sooner than the control. And then again, where to go from here? Replacing permanent magnets with an electromagnetic coil. I believe I'm reaching the end in terms of dropping permanent magnets in the direction of their north to south pole. the field they put out is too static, and they tend to rotate and fall sideways. And once the dual drop experiments are conducted, I believe the next stage is building a pulsed DC electromagnetic solenoid style coil. Such coils have a north and south pole, as mentioned before, and the field they put out will be far more dynamic than that of a moving permanent magnet. I am envisioning a miniature basketball-sized device, about 6 to 8 inches in diameter, using like a DeWalt FlexVolt power tool battery capable of 60 volts and very high amperage to provide the power inside the freefall device. They have clones of such batteries, and I will most likely buy one of those as they're far cheaper. And then also including a gyroscope or reaction wheel at the center of mass, so it doesn't really rotate and it falls mostly vertically. And of course, an electromagnetic coil starting near the front of the freefall object, extending back to around the mid-circumference of the object. That's it. That's my presentation. Check out my other work. It's available at robertfrancisjr.com. And can anyone endorse me on ArcSiv in the physics, general physics category? ArcSiv requires that users be endorsed before submitting their first paper to a category. The endorser would need to be published in the general physics category. If you can, please reach out to me at my email address, me@robertfrancisjr.com. Tim, you're muted.
Okay, sorry about that. Equipment issues today. Yeah, it's one of those days. Okay, sir, amazing presentation. Amazing presentation. Let me bring everybody in. Andrew has his hand up. Before you go, though, let me do this. Okay, I think we get the whole. Oops.
Oh yeah. That's
okay.
The preliminary without
Guys,
the IRB now.
Okay.
Let's put our hands together and give Mr. Robert Francis Jr. an enormous applause.
I would like to ask Robert a question.
Sure.
Okay. Hi, Robert.
Hi.
I was very interested in what you did with respect to solenoids and magnets. Now, I know what your idea of doing solenoids is. I'm going to raise it to the next level, just something for fun as a thought experiment. What if you made a time varying change in the magnetic field, let's say with respect to a solenoid, let's say you go from low to high or high to low, let's say you go from low to high. So let's say if you have a time varying magnetic field, let's say you go from a low field to a really big one. And then let's say you do that, like a pulse.
Yep.
The reason why I'm suggesting a pulse is because of the fact is that when you were talking about the Casimir effect, is that you were imitating, which you might call the Casimir effect, is modeled upon the idea of infinite plates. So, but what you can do though is you get a sharp increase in the strength going through the magnetic field. Going through the Casimir coil imitation through, like what you're doing, is you might get close to the actual Casimir effect, because you're not going to get there if you just even if you have a solenoid, but as you had a time varying, but as you increase it and you do it very rapidly, almost like a very sharp pulse, as you drop it. That might change some of the the polarization or whatever you think you're doing with respect to the remember what you said what in your object, that certain things were being adjusted?
Yeah, I tried the tilting and to induce wobbling to try to increase the dynamic aspects of using a moving static magnet.
So what I'm saying is that you change it from being a static, so you just sharply increase the magnetic field and see if that changes anything.
That's definitely what I want to do, is break it up. I don't know, use a MOSFET or IGBT and take the power from the batteries and then chop it up and put really, really high pulses into the electromagnetic.
Well, what I'm just simply, let me tell you the reason I came up with the idea. You know about Lenz's law? Lenz's law. The EMF force.
Yeah,
Lenz's law.
I'm familiar. I've heard the term, but it's honestly been a while since I looked at it. I don't know. I don't
Go ahead
remember.
and take a look at it, but just simply is you don't want to. Well, I just am saying you have a linear but sharp increase in something like a current or where you're putting through the coils. You don't want to make it exponentially look like it's exploding, but you could do something like the equivalent of Lenz's law or some other force like that, and put that right in and see if it does anything. I'm trying to get you. You were talking about some sort of approximation of Casimir plates, and you're talking about adjusting, so to speak, something at the material of what you dropped. So I just simply am thinking about how you could put a spike of energy through it, something like that, and get as close as possible to the Casimir plate idealization as possible. So my money is that you just simply just crank up the voltage, but you do it you find something that gives something like an energy jolt, a pulse, and see what that does to it.
Okay, yeah, I haven't worked on it. I put it on the back burner, but I was looking into Marx generators. I don't know how I'd be able to manage to fit one
March
of those.
generators?
Marx generators.
Yeah, I'd heard the term. They might actually work.
Yeah, they can put out a very high pulse, but I don't think I'd ever be able to fit it into the free fall object. So,
Well, no, I just simply bring it up as an idea, just something to play with. It's just, if you have some money to burn, you want to have some fun with it, just try it.
Thank you.
It's just something, it's a cool experiment. I'm just trying to raise it to the next level.
Yeah, me too. Thank you.
So
Awesome.
mind if I go next?
Yeah,
Okay.
Go for it, Michael.
So thanks, Robert. You clearly put a lot of work into collecting all that data, and I really like the automated drop tower. That clearly reduced the error bars by quite a large amount. The thing with north-south, north-south, or south-north-south, well, the thing with a single dipole magnet, effectively, because they're joined in the middle, is, it has, how do you stop the magnetic effects from interacting with the rest of the environment? You would have to enclose that in some permalloy or some metal that, like your magnetic field, if it goes out into free space, you're going to interact with anything magnetic. So I don't see how.
Good thing though.
The other thing I noticed with your earlier, I did this as a short list of things.
Yeah, your earlier experiment looked like you could even have something like a torque effect or something like that, which you don't want to have.
I have a list to get through here. 1 minute. So the magnetic field going out into the environment will interact with anything magnetic in the soil. Like if you're near a building or anything, like maybe there's pipes, I don't know, and maybe there's some magnetization on those pipes already, and that would bias the north-south configuration to fall faster than the south-north, or vice versa.
Why would it make that one fall faster and not the other ones too, though?
Well, if there's a magnet that's already magnetized in the ground, if there's some mineral, for example, that has a magnetic field that's embedded in that material, then it will tend to repel one and attract the other. And I mean, there will be some magnetic susceptibility if it's not a hard magnet. And so if it were a hard magnet, you would see one repelled, one attracted perfectly. But if it's a soft magnet, then you wouldn't see perfect attraction versus repulsion. The attraction would probably work just fine, but the repulsion wouldn't. And that's kind of what we seem to see with the north-south versus south-north. So it seems like maybe a magnetic mineral in the vicinity. But this is the other thing I wanted to mention. What are you using for your drop tower? Did you say you were using a ladder? What's the ladder made of?
No, I used a chair. It was a wooden chair.
Oh, so this is not a large distance then?
No, it was only being dropped the ones with the drop tower, it was 195 centimeters, which is a little
Oh wow, that's nothing.
less
Yeah.
than 7 feet.
Well, I would recommend setting up your automated drop tower on some maybe
I'm trying to do it on wood.
I was thinking,
like a fiberglass pole. I would say a fiberglass pole would be fairly good, but that can vary with the wind a bit. That can get hit by the wind. So you may want maybe 3 fiberglass poles, so you have a tetrahedron meeting at the top, so it's got some stiffness to it, and that'll be better. It's not perfect, but some fiberglass poles to make some tall structure. You could have 20 feet then easily, and then your error bars would be way lower.
I mean, you saw the video from the drop. I mean, it was sideways. I just used 2x4s, and then the connecting hardware was all stainless steel 316, which isn't supposed to be magnetic.
It's slightly magnetic, but it shouldn't matter for the purposes of this experiment. It should be lower than the error bars over 2 feet. But certainly fiberglass will not be magnetic appreciably. So you could use a tall fiberglass rod to make a very tall drop tower without magnetic components.
I'll have to look into that. I know I can get 2x4s fairly cheap at Home Depot. I'd have to look at fiberglass pole prices to make a determination.
Wood will work. Wood will work fine if there's a long enough piece of wood. The issue then is even with stainless steel, you're going to have eddy currents in the stainless steel. That's going to change how the magnets drop. And then the other thing I wanted to mention is in your first set of data, it looked like maybe the north-south, south-north magnet did have a little bit of a weird thing going on there. It was not. It was earlier in the experiment, it was falling faster, and then later in the experiment, it was falling slower. And almost nothing had so much variation in the behavior. So I think that really should be again
more research.
That's yeah. Especially now that you have a setup that has lower error bars, you should really look at that again.
The only question I was trying to raise was just simply trying to avoid having torque hit the drop of your object.
That's a good one.
Having a torque effect.
Yeah, that depends on the release mechanism.
That's exactly correct.
To rotate it and stuff like that. That it's causing rotations and stuff like that.
Yes.
Yeah. I'm hoping, and I could be ignorant on how their algorithms work, but the Bosch BNO 055 IMU has fusion algorithms where you can set it to a mode where it eliminates the magnetometer and then just fuses the accelerometer and gyroscopic data together to give you the accelerometer output data. But I don't know if it's perfect. I was trying to use an open source Arduino library, but it had been the person stopped updating it. It's no longer being updated, so I'd have to write the drivers for my.
Mute their microphone. Someone's got feedback.
Well, that was my hearing aid. I apologize. That's my feedback from my hearing aid. I apologize.
No worries, no worries, Andrew.
If you're not talking, just hit the mute button, please.
Yeah, I apologize. I turned the hearing aid down.
Robert, sorry to interrupt with that. I couldn't really.
Yeah, well, I apologize for that. That's just my deafness. I'm legally nearly deaf right now.
No worries. No worries.
Okay, but I apologize for the inconvenience.
No big deal.
No worries. It happens. So we're having a lot of technical audio and other issues today. So, Robert, back to Michael's idea. I would say if the points Michael made, the air resistance is and wind currents is probably the number one factor, and then followed by the eddy currents if you can eliminate that. So I was thinking, you could build a wood frame structure using like Japanese nailless framing techniques, and build you could build a 20, 30 foot tower somewhere with out of wood, far enough away from stuff that you could, and then wrap the thing in like plastic really cheap. I mean, this should be a Mythbusters episode where they build a drop tower and do this experiment.
I did think about using PVC pipe and then because I have a HVAC vacuum device, but it just seemed like it would be very, very difficult to.
The problem with that is you have to. I mean, just basic Heisenberg uncertainty principle. Take it at the top, and then do the drop test of the variation of how far it will fall with just that standard variation of the mean. It's not gonna work inside of that tight of a cramped space. You need more area. You need a wider area. You know what I mean? Because the variation of just where it can fall. I mean, unless you got a 10-inch diameter PVC pipe. I mean, they have PVC pipe that's big enough that's like.
That's true, though. That's true. If I do end up building the electron
that would
be way too big for the PVC pipe.
Go ahead, Drew. I want to hear Drew's idea.
Okay, right now you're doing drop tests, which you're just assuming the Earth's gravity, and that's wonderful. But if the goal here is to find out if this thing reduces inertial mass, why don't you switch to a spinning device with a simple little motor and all of your magic on, a ring of some sort, I don't know, whatever. And then you're spinning this thing, and you're measuring the rate at which it's spinning, and then you activate your magic, and it's going to spin faster because it's got more overcome power than it had a few seconds ago. That would be a very convincing argument, because you could then turn your thing off, and then all of a sudden the inertial mass comes back and you'd slow down.
That's a very cool idea, Drew. That's so that would be testing inertial mass instead of gravitational mass. The assumption is usually that they're the same thing. But that would also be a very interesting test. Robert, you were mentioning using solenoids. That would be a perfect setup to use the solenoids with. You would take something, you'd spin it, and then you would power up the solenoids or turn them off, and the spin rate should change if the inertial mass is changing. That's a cool idea.
And
let me. Would you like to show the classical result that the inertial mass is directly equivalent to the gravitational mass, or do you want to actually show that there's a difference between the two? What would you like to achieve in the experiment?
To show there's a difference.
Okay, to show there's a difference, and you do it without having a without considering thermal effects.
So the way to show a difference would be, you would spin something at an angle. So there's a lever arm, and it's down at some angle.
Okay.
And if the inertial mass is the same as the gravitational mass, for a given speed, you know what the angle should be if it's the same. And the spin speed will change, but the angle will change by a different amount than you would otherwise expect if the inertial mass were different than the gravitational mass.
And if you determine that you have a difference between the inertial and the gravitational mass, are you going to do what type of statistical analysis are you going to use in order to show that? There would be some sort of error bars. What type of statistical analysis would you use?
Well, I just came across one yesterday. I posted it.
You're using for the drop test
today on numerous subreddit forums. And one of the hypothetical physics ones said something called ANOVA, which, to my understanding, you're kind of compare the error bars of the different objects you're testing to see that the error bars are just about the same height all across, rather than one having error bars that are significantly larger than the other test devices.
So I have one question. Is it an interaction between the magnetic field and the gravitational field? See, I am coming with fundamental aspects of magnetic field, the grand unified theories. So I think the magnetic gravitational field is not the primary field. I think the primary field probably in the ultimate universe is the magnetic field. Now, we know that the photons and the gravity effects, Einstein has shown, the bending of light. But in this case, the magnetic field can either augment or add to the gravitational field, which means that it can act as an anti-gravity effect. So it can actually slow down or make it faster, depending on the configuration.
I
Is that
don't.
possible?
I'm sorry. Go ahead. Keep going.
Yeah. Is that possible that in some configurations, the magnetic field acts along with the gravity and then pulls the object faster? The other configuration, the magnetic field acts against the gravity, so it slows down. It's an anti-gravity effect.
But I don't think this is related to gravity. That's why the analytical balance tests came in, and where all different magnet configurations all had the same mass. But
Yeah, you have normally the 9.8 meters per second is the gravity, right? The gravity due to Earth. But you have that higher acceleration, sometimes 10.8. I think you have sometimes the lower one. The acceleration is slower or faster.
yeah, I mean, for the most part, I'd say it was pretty close to 9.8. But yeah, it might be worth looking into some of the others. The repulsively coupled ones again in the future.
Oh, okay. So you can try what they're saying about the spinning things. So
Yeah,
again,
that's
initial.
true. I actually saw that on ChatGPT as a recommendation when someone said, someone in the forums was like, well, conduct other tests that measure just inertial mass, and I didn't know any other than the one I was doing, and it recommended rotation, attaching it to a rotating.
The nice thing about
Okay.
the rotation, by the way, is you can integrate the data over a long period of time, and so if you have large error bars, otherwise you can just take data for days. You don't have to reset up the test. You don't have to test for 10 seconds and then do another test for 10 seconds. You can just set it up to run for hours or days and collect data, and then you see if your error bars are overlapping or anything by the end of that.
So, guys, let me jump in here for just a sec.
How
Bruce
many
Cornette-
how many tests would you be performing, and how long would be the
Andrew,
duration so you
hold
could
on,
get
buddy.
a complete set for a data analysis?
Hold on just a sec. Bruce Cornette just emailed me. And so Bruce he doesn't have microphone access. He does have a recorded presentation. So we can play that, or we could do is postpone, or we could do it after open discussion. I mean, it's up to you guys.
Oh, no
I'm pretty
problem.
mellow.
I was just interested. I was just interested in the experiment.
Oh, yeah.
I don't care. I'll shut up. I'm not trying to hoard it. I just like the experiment.
No, it's different. Yeah, different stuff. Different. We're changing topics a little bit. That's my fault.
Go ahead.
Let's go back to Robert's stuff. Let's discuss that for more. Maybe give it until you guys are done. And I'm going to take myself out for just a bit, and I will be back in just a minute.
Okay. But yeah, so I was thinking of either 2 times that, so I get about a 14-foot drop, or make it 3 times for about a 20-foot drop, and then with the dual drops to finally, say, okay, is there real concrete video evidence the objects are being released computer controlled? Which ones hit the ground first? Do they hit at the same time?
So Robert, I put an article link in the chat here. You should check it out. It's
Okay.
about there's an inertial mass difference detected when things are spun right, but not when they're spun left, or clockwise versus counterclockwise. Probably it would work the opposite way in the other hemisphere of the Earth, but that's something to also look at.
It might be due to the materials used in the flywheel, because
No, it's not. It's not. They correct for this in the experiment that you just check out the paper first. Just check. Don't make any assumptions about it. Yeah, they did a very thorough job, and their error bars are surprisingly low. It's easily a 5 or 6 sigma result they've got here. So that is very interesting, and I would be very curious to see whether the effect is even larger when you're spinning magnets instead of just some other material.
Well, Just a comment on this. I have run across R.H. Eskridge. I don't know if you've heard of Amy Eskridge is much more known, but this was her.
She was in our group for a while. Yeah.
This was her father, and he did a paper with NASA, and he rotated a disc of bismuth inside a kind of a shell.
Yeah, that's also very
direction, and it increased weight, and it rotated in the other direction, and it decreased weight. And my hypothesis is because bismuth has an unpaired proton. So I suppose trying to
unpaired electron, no, unpaired proton. No, what do you mean unpaired proton?
Well, we know that unpaired electrons create a field. They create a magnetic field. And you can like rotate an iron bar.
Unpaired proton in the nuclear shell structure?
Yeah.
Interesting. That's something I'm going to have to look into then.
Yeah, magnetics. Magnetics is all about aligning, unpaired electrons in materials to generate magnetic fields. But
so gravitomagnetics might involve the nuclear shell structure. That's an interesting insight. I hadn't considered that actually.
Yeah.
So this article I linked is a similar result. They're just using steel. They're not using anything special in their material. I'm sure bismuth has an unusually large response for this sort of effect. But check it out. And if you're studying the spin effect, that would if you have something on a lever arm, this is important to look at because it's showing that there's no result if you spin in one direction, but there is a result if you spin in the other direction, depending on where you are on the planet.
Huh.
Yeah.
It's interesting. I just had one very short question: is that if you did see a difference between the inertial and the gravitational mass, if you actually did come up with that, you confirmed it. Do you expect that the type of material that would be involved would make a difference in terms of what's in the magnetic field, or no?
I assume it's just creating a dipole magnetic field and moving
anything that creates a dipole magnetic field would work then, in terms of creating the difference that you are trying to seek.
Yeah, I don't think it matters the type of magnet or anything like that. It's just the dipole field. And that's why I mentioned the alien reproduction vehicle with the solenoid coil. That has a dipole field, and I think that's how it's able to go faster than light. I don't think it's using warp drive. I think it has inertial mass reduction from that coil, and it's so much that it's even relativistic inertial mass reduction.
Yeah, I think in terms of the structure, the magnetic domains are the key things that says it's ferromagnetic or paramagnetic, things like that. The magnetic domains. So the alignment in each of the magnetic domain cells is the one that's going to guide its magnetic properties. So so you can, depending on the configuration, it can align itself or go against each other and reduce the magnetic effect or augment it, extend in terms of materials, So one thing you can try is to have isolation chamber. You have an isolation chamber where all the other effects are cancelled out. And then you put through that chamber, just in that chamber, you drop the magnet. So all other effects are not affecting that thing. Maybe if it's possible, you can try that.
I'll have to look into it. My budget is kind of fixed, but we'll see.
There may be simple ways of doing that isolation chamber. Vacuum or something, you can just pump out air. Like he said, the fiber optics tube. I used a chamber, fiber optics chamber, and it's not a very long thing. It's like 2 meters or 3 meters, right? Yours. So you can construct simple thing and then pump out the vacuum and any other thing. So then air effects and everything can be nullified. And then you have only mainly the gravitation and the thing and the magnetic effect coming into picture. So it may not be very expensive, but I don't know. The materials are costlier. It comes to become costlier and costlier. So we'll never know.
Sorry, I just dropped a link to Bruce Cornette's presentation into chat for everybody, and I'll drop that in just a moment. So the
Oh, I see
original
that right
idea
overhead. See this paper?
the original idea was Bruce was going to record that presentation and then do a Q&A. He's not able to be here for the Q&A. So it is just about oops. Sorry about that. And let me take a look. Oh, it's about 53 minutes long. So so I don't know. What do you guys think? Should we try and play this? I mean, or do you want to go to like lab updates and open discussion? I think we've already kind of lapsed into open discussion, but
What was the topic of the presentation?
so the title of it is Evidence for Mental Telepathy Between UAP Pilots and Observers on the Ground, Hudson and Wallkill River Valleys of New York. I'm happy to play it. I've got no particular issues there.
Yeah, I grew up in the Hudson Valley. Yeah, I had a similar experience there.
Oops, that's
Weird.
that's the wrong
Oh,
one. Sorry.
I could do it one way or the other. What do other people think?
Guys, what do you think?
It's fine with me.
Okay, so
I guess we'll check it out.
yeah, I'll tell you what. Why don't we do that? I will take everybody out then, and we'll cross our fingers. So this is a 1 hour presentation. I will see if I can make this thing work.
Go for it. Go for it, Tim.
Okay, so that is his. Oops, where's my screen? Okay, there we go. And I'm gonna take everybody out. Okay, I will mute myself out. Okay, and I guess just let me know if you guys can hear this. I think you can.
Evidence for mental telepathy between UAP pilots and observers on the ground in the Hudson and Wallkill River valleys of New York, based on an 11-year study from 1992 to 2003 by Dr. Bruce Cornette with the help of Dr. Ellen Crystal. This is an infrared map of northeastern United States showing the position of the UFO corridor across New York into Massachusetts. Dr. Ellen Crystal began her study of the Pine Bush UAP phenomenon in 1980 before Hynek and Imbrogno published their book in 1986 on the night siege or UFO phenomenon in the Hudson River Valley. My involvement with the Pine Bush phenomenon began in 1992 when I discovered that I lived near a UFO hotspot in Middletown, New York. I contacted Ellen Crystal, who wrote about this hotspot in her book Silent Invasion. Published in 1991, I went into the field with her and saw UAP on my first night out. I took time exposures to document flight paths of UAP and recorded their sounds. Then I began a 24 square mile magnetic survey in order to detect underground electromagnetic activity. These are the shapes of the UAP that I encountered during an 11-year study in the Wallkill River Valley of New York. Most are distinctive from conventional aircraft, being triangular in shape or diamond shape. But then we also had shapes that were resembled and copied, mimicked that of conventional aircraft, as shown by the DC-9 type in the center, which had no external engines on it and no windows on its fuselage or in front over the flight deck. All of these UAP could stop, travel at very low speeds, or accelerate to supersonic speeds.
but it doesn't look like a jet. Wait a minute. This is no jet. I'm looking through here. It's just like, my God. What the? Boy, you guys got good sound here. Lots of turbine sound.
Hey, it is just staying right back there behind the trees.
I hear it now.
Okay, we got another light on top. This is the diamond. Oh my God. This is definitely craft. Oh, that top light is moving forward. And I bet it's going to come down to the side of the other one. I see the outline. It's a perfect triangle. Yep. Well, wait a minute. We got a light at the tail, way out in the back. Notice as the lights are flashing, it's not illuminating the tail. The tail light is not flashing. So that... Oh, that's typical sound of the manta ray.
Well, that sounds like a jet.
Well, that's exactly what the manta ray does. I have a perfect copy of this. Yeah, that is the manta ray. And it makes a sound like that. Whoa. Just turned on searchlights. What the hell? Yeah, pointing down.
Cornette framed a distant image in his Minolta XG7 camera viewfinder. I went to push the shutter button. Suddenly, a voice in my head loudly said, "Wait!" I looked at the pilot to my left and at the Japanese cameraman to my right, but neither was talking to me or looking at me. I went to take the picture again, but as I started to push the shutter button, the same voice said, "Wait!" So I waited, holding my camera and pointing at the same area. Suddenly, the same voice said, "Now!" I pushed my camera button. The witnesses in the helicopter saw a bright flash of light marking the path of an object flying in front of the helicopter, traversing the valley in a second. The helicopter was gently bounced by a shock wave. The pilot moaned in surprise. There was no sound. This type of encounter happened 2 more times in a period of 20 minutes. 1/1000th second shutter speed. Michael Schratt thought that one of the large craft that people had been seeing during the night siege in the 1980s might have been a prototype to the B-2 bomber, and he went about comparing it with diagrams and models that people had proposed to be an experimental human technology rather than an alien spacecraft. But it wasn't until October 1997 that we got evidence that Michael Schratt's theory is correct. A group of us from MUFON gathered on the farm fields of the Owen Dairy Farm in October 1997 in order to see what was flying over that area at night. We were treated to a very large boomerang-shaped aircraft that came in to land at Stewart Air Force Base to the east. We even captured on radio communication between the pilot and the air traffic controller, asking that the runway lights be turned up nice and bright. During the night siege in the 1980s along the Hudson River and Taconic Parkway, very large ships were observed by many people, thousands of people, and these continue to be observed in the 1990s. Ellen Crystal observed the Westchester Boomerang, as it came to be known, in the Hudson Valley along Route 17 just west of Chester, New York. I show pictures of this large craft that has a tail light sticking out way in behind it, much like a separate orb. And Ellen stood on the side of Route 17 with her video camera and recorded that craft rotating above her. And it's one of the best images that we have of this enigmatic machine that hovered in the night sky as traffic passed underneath it. During a 23-year period between 1980 and 2003, thousands of people observed UAP in the Hudson and Wallkill River valleys of New York. I personally recorded over 140 sightings with time exposures, videos, and audio. Then, 21 years later, another occurrence occurred in the Northeast, but this time involving drones throughout the Northeast that involved at least 650 drone-related sightings between 2024 and 2025. In addition to military and hobby drones, observers reported orbs, light orbs, or plasma orbs that appeared, and some of which they saw transforming into drones. Plasma orbs have been observed in both the 1990s and the most recent November, December, and January sightings of drones and orbs. These are not conventional technology by any stretch of the imagination. They demonstrate differences that cannot be duplicated by human aircraft or drones. Bright white orbs have been reported flying with drones in New Jersey, Pennsylvania, New York, and Connecticut from November to January, February of 2025. Some of these orbs have been witnessed transforming into small single-engine airplanes. Back in 1992, I had such an experience in the Wallkill River Valley, where along 211 East, I observed a bright orb coming towards me and transforming stepwise into a single engine airplane, even though I could not see the physical structure of the plane. Its navigation lights, etc., matched that of a small plane, and the sound it produced was that of a small single engine plane. The UAP and drones that have been witnessed from 1980 to recently come in various sizes, from very large at 300 to 900 feet in width, to medium to small at only 5 to 10 feet in width or length. Whereas the UAP that I witnessed in the Wallkill and Hudson valleys during the 1990s were of conventional aircraft size, because they were trying to disguise themselves as conventional aircraft to the residents and people on the ground. The triangles even had navigation lights in positions resembling that of conventional aircraft at night. The diamond-shaped manta ray even had the capability of shortening or retracting its tail in order to resemble a triangle. The drones and UAP that have been flying over New Jersey and New York and Connecticut during November 2024 to 2025 are much smaller than the ones that we've been seeing in New York during the 80s and 90s. There have been so many sightings of drones and UAP in the last 3 months over New Jersey, New York, Connecticut, and Pennsylvania that it almost becomes a competition of who can create the most convincing drone in the sky. And it becomes a problem when people are describing orbs, spherical orbs that transform into drones or into small planes. These are probably not made by human technology, whereas others clearly resemble those of man-made drones. George Filer is trying to keep track of the drones, which appear to originate from the Atlantic Ocean. They are still flying regularly in New Jersey as of January 10th, 2025. The large ones, according to Colonel Joe Abegg, are as large as vans. It appears the government has apparently told the media to stop reporting them. George Filer's contacts in New Jersey and the area east of Philadelphia, Medford, are still reporting them. They have narrow wings about 10 feet long with flashing lights, including a bright red tail light. The entire fuselage is lit up with strong white lights, and some appear to have searchlights, perhaps to find food. Our deer have disappeared for now. These drones that look more like UAP or UFOs, and they regularly pass over military facilities. Smaller 10-inch drones are flying near most of our aircraft. In flight, the wings appear stronger than the photo, but seem too small to function to provide lift or aerodynamic functions. iPhone cameras pick up a clicking sound, but no engine noises. Courtesy, Major George A. Filer III, retired U.S. Air Force. Drones come in various sizes, from very large to very small. Many of them, even the small ones, seem to have wings, but of questionable aerodynamic function. In one particular case, a Boeing 707 light drone or craft unfolded its wings. When we first saw it, it was a cylinder, and then it flew away from us, and we chased it down country roads, where it stopped and turned around on a dime and flew back over us. In other cases, we have these tiny drones that Robert Scheidt has documented off the California coast near Los Angeles and Marina del Rey, in which they have wing-like appendages and chase helicopters, government aircraft, over the bay. quite frequently diving into the ocean or coming back out. These are clearly not man-made craft. A Boeing 707 light drone or craft unfolded its wings. When we first saw it, it was a cylinder, and then it flew away from us, and we chased it down country roads where it stopped and turned around on a dime and flew back over us. Compared to recent reports of drone swarms in the Northeast, what was scientifically documented in the field between 1992 and 2003, further northwest into New York and the Wallkill and Hudson Valley areas. Supersonic flyby, silent with no violent shock wave. Use of plasmas rather than lamps for lights. Performed aerial maneuvers and created sky glyphs. Targeted individuals on the ground and went out of their way to make contact with humans. Can fly silently or project various types of sounds. Can influence electrical devices remotely. Typically, takeoffs and landings occur in farm fields, not airports, and they can pass through trees and into the ground. Aerobatic performances done at night below 1,000 feet altitude over populated neighborhoods, right-angle turns, can move their lights independent of the craft and can time those movements to the thoughts and actions of people on the ground. The pilots of the UAP knew that I was taking time exposures, so they created skyglyphs in the sky as a form of communication. One common skyglyph was the letter S, and it was performed multiple times. This symbol could come to mean many things, anything from ship, star, solar system, sun. But the important thing is that both those craft that had individual lights and plasma lights and those that were orbs all created these types of events for my camera deliberately with intent. And this is not something that one sees happening in New Jersey, Pennsylvania, Connecticut, etc., for the more recent drone swarms that are being reported. There was a much greater connection, intellectual and mental connection, between the pilots and my camera on the ground. After starting to photograph near Pine Bush in June of 1992, by June of 1993, it became clear that the pilots of these craft were creating skyglyphs as a form of communication. One spectacular happened on the 2nd of June, 1993, where an orb ascended from the tree line up into the clouds and then traveled south. This orb, right before the shutter closed, on the first time exposure sent out an orange orb from it that descended rapidly towards the ground and did a series of very distinctive loops that formed a symbol known as the treble clef, but it was reversed in orientation from that of a normal treble clef, a symbol for sound. But it wouldn't be until I had recorded many UAP sounds that I began to realize that they were creating their own kind of music. And this music or sound followed the treble clef, but the symbol was inverted or reversed, like the sound was a reverse Doppler effect.
It up. Whoops. Still not clear. I think this is the military something or other. Whoops. Shaking. Whoa, it's loud. Wait a minute. That body is solid. That body is solid. Where the hell is it? Did you see the body on that? No. It was solid. That was a solid body. It was a solid triangle body with extra things in the front and back. Shit. I took the video camera away because I wanted to get a better look at it. It up. Whoops. Still not clear. I think this is the military something or other. Whoops. Shaking. Whoa, it's loud. Wait a minute. That body is solid. That body is solid. Where the hell is it? Did you see the body on that? No. It was solid. That was a solid body. It was a solid triangle body with extra things in the front and back. Shit. I took the video camera away because I wanted to get a better look at it.
Whoa. Just turned on searchlights. What the hell? Yeah, pointing down.
The manta ray makes U-turn over Pat and me in a field and produces oscillations. Frustrated by the oscillations, not knowing if they were due to camera vibration, I hit my camera in time exposure B so that I would have a clear distinction between UAP oscillations and camera vibrations. Conclusion: the pilot deliberately makes his lights oscillate right after I open camera shutter. So how did the pilot know when I opened my camera shutter? Encounter with Pat and Bruce on 26 March 1994 near Pine Bush, New York. A triangular craft hovered at the end of West Searsville Road and waited for me to set up my camera. It produced a light tail just before beginning its run towards us. Note: light tails involve only the central two lights and not the outboard running lights, indicating intentional behavior. The pilot knew when the time exposure began. Black and white infrared picture of a craft slowing to a stop over a farm field and waiting for the camera shutter to close before diving out of sight and disappearing into the ground. The lights on these craft are not lamps. They are hot plasmas that register intensely on infrared film. Lou has said all along, we are not alone. Now he has added, whatever that means. But he has emphasized that these are completely unknown technology. They are not domestic or foreign. He says that this is not a government psyop. So what does that leave?
underneath. They're all at the outer edges. Nice sound. Jeez. Oh, sure.
What was scientifically documented in the field. UAP can move their lights independent of the craft and can time those movements to the thoughts and actions of people on the ground. UAP lights would oscillate soon after I opened camera shutter for time exposures. When I stopped thinking open shutter or close shutter, the oscillations after open close shutter stopped. The pilots of the UAP showed me that they knew what I was thinking and made light movements synced with my thoughts. Humans cannot do that. A UAP encounter on the 5th of October, 1993, near Pine Bush, New York. This UFO produces distinct and different changes in light trace just after the camera shutter opens. The first one, 22 seconds, it brightens at the beginning of its light trace. The second, 12 seconds, it produces a tail at the beginning of its light trace just after the shutter opened. And the third, 10 seconds, it produces an oscillation that dampens very slowly. Very few witnesses have recorded similar phenomena, but then very few field investigators have given our visitors photographic time exposures with analog film. On the 7th of July, I had an encounter with Ellen Crystal of a strange UAP flying west along Bruin Turnpike, west of Wallkill, New York, and we pulled over and stopped as we saw it coming towards us like a pair of car headlights, except those headlights were above the trees and it was paralleling the highway. I got out my camera and set it up, and it stopped and waited for me to get ready to take its picture. And then it started to move. And every time I advanced the film to the next frame, it dropped in altitude and then continued its path above the trees. And finally, the last time, it was going through the branches of the top of the trees, and it stopped and disappeared over Dwarkill River. In order to determine if the UAP pilot was reading my mind and therefore knew when to produce an oscillation in its lights, I delayed saying or thinking open shutter, and when I did delay it, the oscillations were delayed also. Sometimes when I said close shutter, the pilot would produce oscillations just before the shutter closed. And I wanted to test that hypothesis also. Was the pilot reading my mind? So I would say close shutter. Before I closed the shutter, I waited and then closed the shutter, and the oscillations occurred coincident with my thought or statement of closed shutter and not with the actual closing of the camera shutter.
Geez, looks like a congregation, whatever they are.
Yeah, that's what the hell. What is going on there?
I've never seen this before.
There's 4. I got all 4 in the video.
On the 29th of April, 1993, the sightings camera crew showed up at the Wild Farm along West Searsville Road in Montgomery, New York, and set up their cameras. Ellen and I, along with her friends Rich, Ralph, John, Keith, and Steve, also showed up and waited for something to happen. The sightings camera crew had come from California in order to view the phenomenon of the Pine Bush UAPs. What we didn't realize was that 6 craft would show up at 8:49 p.m. and put on a spectacular performance before our cameras, 2 of which would make runs at the cameras, turn in front of us, and then fly back and dive below the tree level and disappear. A black triangle, one of the craft, made a run at our cameras, turned in front of us, and then circled back to its area of origin. Then the manta ray came at the cameras and turned in front of us sideways, projecting its lights on its bottom and flying directly past us at well below stall speed with a loud sound like that of jet engines. What is important about this encounter is that it was filmed by multiple cameras and witnessed by 8 or 9 people. The craft made similar tails on their lights when my camera was open to take a picture of them. I have 4 of them in which all the tails were generated at the same time, but they were not due to camera vibration or movement.
No, well, not even a C5. A C5, we would still be able to see wings
I
and
remember we seen
fuselage.
C5s and you'd hear them 5 miles away.
Yeah.
We didn't hear
See,
that.
that came to us and turned at us. You know, this is awfully big not to hear sound now.
And just low to the ground.
Oh boy. Yeah, this is shipped. I mean, a C5 isn't going to bank like that. The hell? Oh, look at this. The hell?
Holy shit.
The hell is that?
Non-humans have been on the Earth for hundreds of thousands of years, and they have left evidence of their existence to all our civilizations since the last ice age. They are nonviolent and very patient with us, but are getting frustrated at how humans are afraid of beings that look and act different from us and are more capable than us. Even our government is afraid of how humans will react if their true nature is revealed, which is why disclosure will never be official. Can humans accept their superior intellect and capabilities, and how they can communicate with us silently by voices in our minds? However, if you seek them out, they will educate you as they have educated me. How do I know that they were reading my mind and responding with movements of their lights and sounds?
Okay, there we go, guys. I believe that was everything. And actually, Bruce. Oops. Oh, sorry about that. That was my other channel. Okay, you guys couldn't hear that. Okay, it jumped from his. I tried to close the window. It jumped from his to like Fox News. I'm like, where's that coming from? So, guys, let's do this. Bruce is actually, you know what? He's here, but it won't even let me add him in. So I guess he can sort of kind of hear us. But let me bring you guys on stage. Guys, put your hands together for a wonderful presentation by Dr. Bruce Cornette. And again, when he figures out, when he's able to iron out his technical issues, this is it's that time of year, I guess, for all of us. Tech Issues 101. So we will just try and make things work. Did you guys have any discussion points on that, or should we jump right into?
I just want to mention I grew up in the Hudson Valley in New York, and I've seen things over there too. So It's just interesting. It's interesting to see. And that reverse Doppler effect was very interesting. Like you could tell like the tree frogs in the background were like you could fake that by running the video backwards and putting the lady's voice on it. But like the tree frogs too, you'd have to edit each of those and invert them. But
yeah, this is
that's fairly convincing.
Yeah.
That's really interesting that he, what I saw did not make any noise at the time, but yeah, it was interesting.
Well, guys, why don't we do this? Why don't we go to Drew? Do you have any updates to share with us, sir?
Just been a day of broken hardware. Turbo went out.
Yeah, it's going around, man. It is going around. That's
very expensive day of broken hardware. Turbo went out again in the coating chamber. I don't think it's the turbo this time. I think it's the controller. So out on eBay, I found 2 of them. Pretty good price, actually. Hope they work.
Yeah.
Good luck, man.
Got a whole bunch of welding done this week. So the big chamber is vacuum tight now. I'm hoping to pump it down tomorrow for the first time. See if the door seals survive all the welding.
And then I'm just checking real quick.
Yeah, that's it.
Okay, I'm just checking. So let me see. Curtis Horn messaged me also. Curtis may be able to pop in. He said, let me see. Curtis said he's preparing a lab update for after 5 p.m. He won't be able to participate before or after. Okay, so we may have missed him, but we'll see. If he pops in, we can get him in. So I guess, guys, why don't we do this? Why don't we just go to open discussion? Rock and roll. So put our hands up in the air. Open discussion, yay!
Yeah. So Drew, I was thinking about what you were talking about with an AC version of this device. It reminded me of, I think it was like a Reddit thread I saw a couple years ago where some guy was like, hey, we had to machine this really weird thing out of tantalum. Why would they make us machine this? It's like, it's not even structural. And I realized it was probably an antenna array. And why would you use tantalum for an antenna? It's not very conductive. Well, if you're trying to do what you're doing, if you have, I think someone was already doing what you're trying to do way back then. And if you had this metamaterial with a negative electric permittivity at certain AC frequencies, then you could you would want to get the highest possible field out of that. So you want materials that will not fail, will not emit matter out of their surface, because like eventually, if you have a high enough voltage on a capacitor, it'll start sputtering metal off the surface, as you well know. So the most resistant material to that pretty much is tantalum. So that was just interesting to think about. And moreover, I mean, Thomas Thompson Brown mentioned that tantalum was a particularly good material to for electrogravitic effects or something in his research. So it's interesting to note some of those pieces are coming together.
Yeah, I actually have some. Well, I'd have to get a puck of tantalum. I've switched over from thermal sputtering to magnetron sputtering.
I'm thinking if you want to make a metamaterial out of tantalum, probably the easiest thing to do is get sheets or wire and punch it or bend it into some shape for an initial test, at least.
Yeah, but if I'm going to do anything with it, I'm going to be vapor depositing it.
I mean, I think for the AC version, the amount of thrust you're going to be getting, I think you guys are right. It's really, I mean, I think the VEM drive is probably also doing something similar. So I think you're probably going to get thrust way over the noise floor. You won't even need to worry about optimizing
that guy up there in Minnesota or wherever he is, is that what you're talking about?
I think so.
Yeah,
I don't know.
That doesn't look like any kind of vapor. That looks like traditional circuit board manufacturer.
Yeah, and I mean that's all you need. He was claiming many
mask and dissolve away
etching. Yeah, right.
Yeah, he was claiming newtons of force and stuff off of that.
There is a killer high line.
Oh yeah, you know what? Here, let me. Why don't I mute Andrew out? Sorry, it's Andrew. It's his hearing aid, and that's okay. It's not a. It's just. It's okay. I think it's electromagnetic interference. I think that the hearing aid is tuned similar to the mic, and it's creating some kind of a feedback loop. But that's.
Yeah. But yeah, I think the antenna that guy's manufacturing.
Okay.
I mean, it's basically just a piece of PCB board. And,
they
off whatever the fractal pattern or whatever it is.
That's a good way.
Dissolve away the metal they don't want to see.
Yeah.
There's no trick to that. That's I'd send that out and have it manufactured somewhere. If I knew what the pattern was.
Right. Well, I have a few ideas what the pattern might want to be, or what we would want it to be ideally.
We need to hook up, man. We need to link up, and I want to get started on that.
Yeah, I mean, I reviewed that document that you sent. It was sent. I mean, some of my other team members thought maybe it was a little overly broad. We can. I'll see what I can do with that. I don't know.
Let's get on a private chat and talk about that.
Sure.
There's a lot of room for collaboration.
Right.
I had one short question, which had to do with it. They had up to Mach 5 or something like that, maneuvers very close to the ground, and that was very, very fine resolution. And I was absolutely astonished. And the reason is because I would expect if something were moving that fast that there would be some sort of a corresponding type of a shockwave effect or something like that, very close to where the people were, something like that. Evidently, something very close to the ground, moving at Mach 5. I saw at least, the estimates that are made in some of the film. I'd like a feedback from you on that, because that was the most astonishing thing I saw in the video. I was astonished.
Yeah, very
It
impressive.
wasn't fake. It was real,
I
but
got
how
no
did they do
comment on
it?
that whole video thing.
It's cool. It's just not
It would
particularly.
have to happen to me for me to believe it. So
Yeah,
I will
I mean,
leave it.
these days AI can fake anything, but I mean, we got to stick to the actionable and the science that's right ahead. Like, Mother Nature can't lie to you, like digital stuff. Like, you got to take it with a grain of salt these days, whatever it may be. But it was interesting for sure.
They could have a cancelling effect, noise cancelling or the shock wave cancelling effect, some kind of shape they could have that will produce configurations that will cancel out any type of shock waves. It will absorb the shock wave or it redirect the shock wave. I think there are some high level things possible. I mean, you cannot rule out that, but could be fake also. You never know. It's very hard to sometimes distinguish between the real thing and the fake thing. And then I have a question to Andrew, Dr. Andrew, about the graviton is a very interesting thing. We are onto it, and I started fundamental modeling with Emmanuel Markoulakis. He's in Greece. I am in the US now, but that's about a micro black hole. So I started understanding that Helmholtz decomposition means that you can decompose fields into what you call as the rotational field and also a translational field. And the micro black holes are the key thing in that rotation things. And the 0 point field is like the gradient field. So from there, I developed, including the fact that the time could be more than just scalar time. It could be rank 6 tensor. And the time actually could interact with the gravity and produce the effect that quantum gravity, quantum gravity. And for which now I am looking at something called spin spectroscopy. I developed that. I mean, it's a very simple tool, but I think it can be used eventually, that you can plot the E over M, which is we will know very well, and the spin, and then it will predict about the gravitons, which are spin 2, and it connects the electromagnetic and the gravity effects. And spin 2 graviton right now is a hypothetical particle. Nobody has been able to ever find that. I don't know whether you can ever find that, because it may be just it may be superluminar, for example. So you may not be able to detect by any experiment we know so far. LHC and things like that has certain limits on the energy levels it can go. But Andrew, your analysis about the fact that you can have so many micro black holes, and then you can have graviton particles, and they create torsion such that they account for most of these big differences in the vacuum energy. That is an eye opener. I think it's an eye opener, and something I like to proceed, along with my research. And I don't think I have your. I mean, I can go through the your article that you have. Then I think probably communicate with you
No
either
problem.
through. Yeah, I don't have the email. Will you be able to put in the chat the email?
Well, let me just say that Torsion had a really bad reputation among some people because it's so badly abused. But actually, which is I quoted some actually very reputable work done at Eric Nuclear Physics on this, and that they were, and I followed that very, very closely. And there are people who are extremely good at it. So, which was I stuck very closely to them. And then the other thing which I did too, I didn't state this, but let me just read this to you. There's a theorem which is called an almost scalar manifold, has a symplectic structure defined by a two form, and conversely, let X be a 2n-dimensional manifold with a two form of rank 2n at each point. It is always possible to construct on X an almost complex structure in Hermitian metric so that phi is a corresponding fundamental form. Well, from that sort of thing, which you talk about fundamental form and everything and so that I was taking that type of structure to look first of all at the creation of black holes, then the link of black holes to graviton, then the link of graviton production to an excited state in terms of a quantum state per black hole that might refer to the gravitons. Then the next question which I was asking was information. You have information and maybe something like action, addition, teleportation between the prior to the present universe. That was assumed in my figure 1. Okay.
So Andrew, if I could push back on that just a little. So like you're going to black holes immediately with that, and black holes are high energy, high curvature, and so very nonlinear, and the linear approximation is not valid necessarily at that limit. So wouldn't the more natural thing to do be to work with axions and dilitons at low energies to unify?
The reason why that's a very good point. But what I was, let me just tell you what I was doing. Was I was talking about the initial. This is why I referred to a BEC condensate, and the BEC condensate's very, very unstable. It doesn't last very long. So the answer to your question is all that is true as you have the how nonlinear that is you are true. Is you have something like a state and evolution. I was referring to just immediate states that occur at the prior to and then the beginning of space-time nucleation. At that
okay, so
then, which is after that point, all the nonlinear stuff comes in exactly as what you said.
So I think the issue with modern cosmology is they all go to the limit cases, which are not well understood at the moment anyway, and more data needs to be collected. Like even now we're seeing like with the that new telescope, what's it?
James Webb.
With the James Webb.
You're exactly
they're seeing like galaxies all the way to the edge of the universe. So it must be much older than the initial estimate. If it even has a finite age, it's hard to say for certain, you know. But yeah, like the universe, the boundary conditions for our universe might be very different than what we think they are. I like Curtis Horn's suggestion.
All I was talking about, let me just explain to you that way, because that's a very valid criticism, and I talked over to Marcel Grossman. I'm talking about the initial state that occurred that might be very simple, and what they evolved to something hideously nonlinear later on. But the initial states are not necessarily, you can't talk about quantum approximations. You can talk about other things. Afterwards, if you talk about the evolution, it turned to tremendously complex bodies. And you are correct.
Well, so it's complex, but it's low energy, so it's mostly linear. So it makes it easier in some ways.
Well, I just talk about something that occurs in terms of just right after the Big Bang. You have
but the Big Bang itself is an assumption. It's an assumption that it may be proven wrong.
That's all I was assuming. If you talk about something that occurs past that point, it becomes a nonlinear monster. Exactly correct.
Okay. Yeah.
But your statement is completely factual, and I'm giving you. Oh shit! I'm tired and getting rung up by idiots. Okay, I turned off the phone. Okay, so back to the point, which is that you are correct, and I don't dispute it. But I'm just talking about the very beginning nucleated point. Just simply, if you talk about a phase transition. I don't know why someone's so fucking insistent. I don't answer the phone. I don't answer the phone. I just wait for people to go away. Anyway, the situation is you're exactly right. So which was what I just talked about. You have something like a phase transition that occurs prior to the present universe and immediately within something like a Planck interval of a time and something like a prop. And so the initial condition. Then after something like by the time you get to the electro week, everything is hopelessly snarled up. Everything gets completely hopelessly snarled up at that point. And
I mean, if you take the axion and dilaton approach at low energies, it's not necessarily the case. You may be able to make a predictive theory which unifies gravity and electromagnetism.
But I assume
at
that
low
my
energy.
answer. Listen to me.
Go ahead.
I am assuming a dilaton type of approach by the scalar field approximation I use.
Right.
That's a dilaton
Okay.
type of model.
Good.
So that's, like what for the phi, which I use, that's a dilaton type of structure. So I use that from the very beginning. And I do it for pretty much the reasons that you said.
Oh, okay, cool.
So
Okay.
which is that you're exactly right to bring this up. And I'd had this criticism from people before, and I'm giving you the straight answer.
Awesome.
So it
right.
was using dilatones.
It's interesting.
Yeah.
So
Awesome.
yeah,
That's
Yeah,
assumed
then
that after a certain period of time, those do turn into an axion type of approximation.
ah,
Well,
You
then I
start
mean, there's
out with a
axions and there's
dilaton type of field. It looks very much like an axion after a certain point of space-time.
well, so there's a non-abelian like conversion you can do between the two, but actually you should probably talk a little bit with David Chester about this because he's got some very interesting math behind this at this point, and I think you would like it. The idea is there's something called the Hertz potentials, which are not.
Yeah,
super
I
well
know
studied.
exactly what that is.
Oh, excellent! There you go. So then the Hertz potentials, he's treating those like the axions, and then the dilaton it seems to be associated with the removing the Lorentz gauge condition, and then you.
That is also true too, but it says I worked with a dilaton field type of thing from the very beginning. But you're correct. I'm not disputing any of it. And
Awesome.
second to their limits, the limits to what I did, and I expect it. And I said people would improve on it. I'm not assuming that it's.
So you're taking that already. Okay, cool. So you would probably be mostly in agreement with David Chester. That's really cool. You should definitely get in touch with him. Then maybe there's some collaboration you can do on some papers. But I guess I mean the natural thing would be to take it to the limit case and see if you can predict properties for the boundary conditions of our universe.
Correct.
Just do not assume that the Hubble will be correct in its measurements much longer. That's all I'm saying.
yeah.
Well,
Yeah.
I have no problem with that. Again, I have no problem with it. Look, let me just give you an example, which was that one of the people who was very Lamontre when he started his idea about assumed a cosmic egg. No, really, not a singular point, but a cosmic egg.
Okay.
And he assumed something like radiation from the point at the start of the universe that was very much something similar to X-rays or something like that. And which was what that it was in some respects just totally full of shit. But he had some of the basic ideas right. This was Lamontre, who was pretty much the genesis behind with other people started what you might call an expanding universe. But he started with the idea of a cosmic egg. And
well,
it's ridiculous.
The idea of an expanding universe, interestingly, if you actually go back, it was from a scientist who visited Rome and some of the.
It goes back even further than that. It goes back to the Greeks. They had Greek philosophers who were talking about in the 3rd century BC. They inferred somehow. They were assuming something like that. They assumed that there were multiple stars, that there wasn't just a sun, that there were multiple star systems, and even one person even assumed that you might have, in their own way, a universe that was not static. So the ideas have been around for something like about over 2,500 years.
Right. I'm just saying, like the paper published for the modern theory of inflation for the universe was published after someone visited Rome and the cardinals were trying to convince them to like have them in the universe.
I believe that too.
Like
Is
there
I
was a
said,
yeah.
is it basically? I'll just tell you my attitude toward it. My attitude just simply was to use something like information theory or complex information theory to talk about a prior to a present universe and a transition. Secondly, which is I was indirectly appealing to the idea of something similar to a wormhole. So you had something like a quantum number in connecting to. I couldn't quite make it work out, so I did this other stuff. Okay, that's what I was trying to do. 3, the dilettante idea, which you used in the very beginning. Now, which is that if something like 1/10 of what I did is correct, 1/10 of it is correct, and someone actually ran with it, I'd be happy. It just is that I have a book by a person like Godfrey Chu, and Godfrey Chu came up with the S matrix theory. S matrix theory in terms of, what that is? S matrix theory that's used for elementary particles. They thought that they could just reduce it to similar to a giant S matrix for predicting elementary particles that would come up, and you wouldn't have to go through something like the quarks and everything to sort. Well, after the development of quarks and the SUN symmetries, there people who had nothing to do with the S matrix. Well, it got revisited something like that early in 2000, and now it's part of string theory. It got reborn. It's used there. I'm not saying it's correct, but ideas go in and out of fashion, and then they work. And so it's what I did. It's 1/10 of what I did is useful to say 30 years from now. I'm happy. It just is that, the average PhD has one main publication in their lifetime, which is their dissertation. And very few people are productive afterwards. And so then the thing is that, and I also go to Landau. I know I was in Russia in 1990 for 1 year, and they had schools in dynamical systems. So I stuck my nose over there, and I was part of a program in applied math. They had a bunch of Russians, so I saw that. And then there were some people who knew Landau. And they said, well, what was the story about Landau's theoretical physics school? I said, well, there's one person, an old man, said we called it his insane asylum. It was his, why was that? Well, because that 90% of the ideas that Landau did were utterly crazy, and we would kill them. 10% of them were pure gold. So 10% of Landau, but a lot of times, he was very quick, very smart, but a lot of what he produced was nonsense. But so he had Lifshitz and other people filter out all the bad ideas, then he put the good ideas in the books, and so they made him famous.
My professor, my thesis advisor from WPI, from an undergraduate thesis, was he told me recently, scientists should live in the realm of dreams, and that's where the real breakthroughs happen. Well, I'm paraphrasing a little bit, but
the point of it is
you shouldn't be afraid to be wrong. Most of the time you're not going to get it right, but then you move it forward with the new ideas.
Yeah, well,
I've mastered that. I have mastered that. I'm never afraid to be wrong. In fact, I like to tell people I'm wrong usually about big things at least 3 times a week. So, and that's why people have said, Tim, you apologize more than anyone I know. Well, that's because I'm wrong about things more than anyone you know also.
Yeah, but I was just referring to what was said about this person in Landau, and it was still Leningrad. The Soviet Union was still going. So this person said, 90% of what he said was crap. 10% of it was Nobel Prize level. So what did we do? We filtered out all the garbage. So we made Landau look like an unparalleled genius. Well, everyone knew better. He was a wild man who just generated ideas like a machine.
That's something to throw that to David Chester. He likes digging through.
Behind every good physicist is a team of suffering grad students.
Okay, and I have Curtis here also.
As I said, I just basically a solo actor a lot of times. I have a room full of books. I have 1,000 books in storage. I have 1,000 books in storage. I have 200 in my room. And, which is I read stuff, I just play with stuff, and I just had fun with it. And so then, which was that my PhD was at the University of Houston. I'll tell you a story. Because I was started off in experimental stuff and some similar to quantum tunneling, NBSC3, and I solved the problem analytically. But which was that my advisor had this person named Gustavo Scardenas who got really burned by liquid helium. He got so badly burned that he got put into the hospital. So 5 days later, he comes back to the hospital, and it's a big fucking mess. So my advisor looked at me and said, well, you have a hearing loss. I'm still partially hearing impaired at the time. This is 2000. He said, I'm going to take you from experiment and make you a theoretician. I'm not going to have another person burned and nearly killed at my lab. That's what he said. I said, no. He said, you either you accept and finish your thing at the theory dissertation or you get out. So I said, I'll take the theory. He said, good. So 2 years later, I finished my theory dissertation and got out. And, it was just simply this, but this is the reason why I ask lots of questions about experiment, because I like experimental details. So, which was that, it's just that I have lots of, like this, I have like this and other things to play with. This is analysis manifolds in physics. On the other hand, I like also to be talking to people what they said about fucking around in the lab. I like that. I like getting my hands dirty. Right now, I just am too poor. I'm too old and poor, which you might call to have access to my own lab. If I did, I'd like to do things, but that's what happened. So my advisor, there's somebody said, "You're next. You have a hearing loss. You are the next Gustavo Scardenas. I'm not going to have this. It creates an absolute emergency." And he had to fill out all sorts of paperwork and everything to sort. So you finish and you get your. So I did a numerical analysis, that theory thing is sort with the fate of a false vacuum. That's what I did, applied to NBSC3. And so I did, like an I versus a current versus electric field. And I solved the problem that my dissertation advisor couldn't do. He failed for 20 years. I solved it. But the thing which was with it, that's what happened. But as I said, though, I just remember what was said about Landau, and it was funny. And so he said, we loved him. We thought he was a great guy, but 90% of his tests, we made certain it wouldn't leave the institute. 10% of it, and boy, we really sold that 10%, and it was absolute gold. That's what he said. Now, I don't produce as many crazy ideas as Landau did. I never produce things of his hot greatest hits, but I can emphasize with the guy. But they were really loyal to Landau. They really, his school alumni they still remembered him, and this was about 1990. They still remembered him.
Yep.
They adored him.
Yeah, you got to have a good relationship with your team and get some good grad students.
He was also too a raging asshole. He was a raging asshole too, but they loved him anyway. But he was a great guy, and so then that's what as I said is that I'll just ask. This is what I wanted to ask him. What I wanted to ask the guy who just took off. It had to be about reformulating things in terms looking at different possible symplectic structures. I wanted to talk about symplectic structures with respect to the geometry of some of that between general relativity, quantum mechanics, and potential.
Oh yeah. I think his. I mean, there didn't. I didn't see the papers, so maybe there's some more math that I wasn't familiar with. But the even just the philosophical, ontological structures he was exploring were potentially useful. Like if you just consider the measurement problem, he was talking about the measurement problem.
Yeah,
like
I remember that. Which I'm also
wave function. I just wanted to mention while on the stream, like the collapse of the wave function happens just like he was saying because we have an ontological error or a.
It is an ontological.
We have a category error where we assume that a measurement is an event at a point, And so when
That's
we make
exactly
a measurement,
the point I was
when
bringing
we
up
make
and
a
glad you
measurement,
understood it.
well, when we make a measurement, we induce boundary conditions on whatever wave function the matter has, and that boundary condition causes what we think of as wave function collapse, but it's really just we are imposing a boundary condition based on our assumptions of what a measurement is,
Which may or may not be
indeed,
there.
indeed, when you go to weak measurement theory, you can have partial wave function collapse. You can have
I know that
collapse over
partial
time.
wave function collapse is much more realistic than the actual full wave function collapse. Partial
Yeah,
function
in many
wave
ways.
cap collapse actually has some sort of experimental data evidence for it.
Yeah. Well, I mean, the assumption is that even in the limit case with measurements at points, the wave function collapse happens over some amount of time, which is imperceptible to us, which is constrained by the physics of the specific situation that we're looking at in some way. But yeah, I mean the weak measurement theory lets you observe wave function collapse as it's happening and stop it part way and all these other things.
I understand, and I said that with to a certain degree, that's also similar to the argument that was made about the because as you look at even something like QED, which is a why did people put in renormalization so they could actually deal with the problem of QED?
Yeah,
well, the situation was with to remove the infinities. Well, to a certain degree, that's dishonest. And another sense is that if you don't put that in, you get hopelessly snarled up into boundary conditions that no one really quite understands. So, which was with it that the renormalization thing is actually we have limitations in some of our logic in terms of how we set up and formulate these problems.
Yeah.
And
actually, in count, we should not use 0. We should say 1, 2, 3, 4. We can actually remove many of the infinities. And also, I want to take about the M theory versus the brain theory. Do you think they are going to have anything substantial? M theory and the brain theory, BRANE, brain theory. Anything?
Correct. I know what you're referring to, and you are correct. I understand the problem. And all I am saying is that I play with a lot of these things. I'm also, too, going to be, at the request of the school, I have a professorship. They actually list me as a professor in China. They want me to do something with tokamaks and to link it right back, to say, the way the tokamaks is observed and other things are at the good first approximating the setup, what you might call initial conditions for what you might call, like signal generation from the early universe. But it's largely for the reason that you were bringing up. It just simply is an approximation used. And they want me, and they have a Susol. They have a tokamak and Susol that they want me eventually to be nose to nose with. In other things, in terms of plasma. And it's partially to get around some of what you're referring to. But that is, if I can stay out of all the fights between China and the United States, was like than tumbleweed.
Yeah, it's a tough situation politically right now, I guess.
Yeah, but you're correct. But I just wanted to say the thing is that I have something like 1,200 books of just stuff to play with. I just do it because I'm an old kid, I'm an old kid. Just as that I'm not senile yet. I'm an old kid. I just do these things for fun. But of course, what you said about the dilettantes is right on target. You remember what you said? But I assumed that from the very beginning. Turns out and I have a paper where it actually proved you had to use something like a dilettante structure in order to be able to formulate what you might call a realistic bound to the cosmological function. Because if you don't assume it's just a dilettante or something like that, that's another paper with it that I could have brought up, but it was too mathematical. And the point of the thing is I did it. It's going to be published probably in about 2 months. And it's going to go partially to the issue that you just raised. So I'm very much aware of the problem. But anyway.
So you mentioned renormalization. I wanted to bring up something else as well. So like
Well,
renormalization.
renormalization isn't wrong. Listen to me. It's not a case of which we have inherent limits in our logic, which we work with.
Right, but so what I was saying is like renormalization could be justified as an effect of a polarizable vacuum, couldn't it?
Exactly the point. But how do we know that the polarizable vacuum has the structure we think it does? As I heard this argument before. The question is that when we do polarizable vacuums, we make a lot of assumptions of how it is polarized and everything to the sort.
Well, that's where we have extended electrodynamics experiments, right?
Yes, and that's where we need
goes.
to have more. We need to have more electrodynamic experiments where we look at the actual state in terms of what a polarized vacuum is. And so I see a lot of mathematical models, and I can come up with counterexamples to each of them, which blow them apart. So we need to have some real experiments done.
Let's do it.
Well,
it's
also
we should
I know,
also.
but
we should connect.
I'm going to go to another point, which is remember when I said that thing about that guy who was talking about the idea of the Casimir plate, and you want to have something, for that drop experiment, and I said, why don't you just only have a spike in an electric field or something like that through the solenoids and everything destroyed?
Well, that's more or less what Drew is doing, by the way, if you're interested.
Yeah, but let me just get to the point which I'm trying to make. The point of what I'm trying to make is that we make a lot of assumptions about the uniformity and the
he was just mentioning
vacuum polarization, and I suspect that none of them are true.
Yeah. Now, at some point, I should jump in real quick. So, Curtis, do you have an update for us? Did you want to do an update?
Yeah, I have a lab update. If there's time, I don't want to interrupt the discussion, but
okay. If you can wait for a bit, then
I'd love to connect with Andrew afterwards, Tim. I should probably head out shortly, anyways. Jeremy, let's also connect.
Okay.
Yeah, but Andrew, to that point, I think Drew has some positive results with his team, which suggests some of the extended electrodynamic stuff. So,
okay, do you guys want to keep talking, open discussion for a few minutes? Or
Curtis can go.
I would love to talk.
Curtis, I want to hear Curtis's updates.
Okay, let me bring Curtis Slide Deck in then, and I'll mute everybody else out. But yeah, I'll just take everybody else out right now.
Sure, I'll be brief, Tim. So, let's see here. All right, thank you, Tim. So this update, things are actually moving. Quite exciting stuff happening. We have gotten a new devices built, and I'll show you the picture in a second. A new device built with 1 millimeter thick discs. Typically in our stacks, we have 2 millimeter thick discs, 8 of them. Now we're having 16, and the theory is that we're supposed to get a lot more push with that, and we'll see if that happens. We're also gearing up to test a few different linear experimental designs, and I'll cover that soon. And also we're working on getting a better driver, because right now we're using a simple function generator and an amp and feeding the circuit, and that doesn't allow us for doing kind of feedback control, and that's kind of what we need to be able to have the what we think is the effect, have it kind of locked in, so and have it over a longer period of time. The problem is that if you put in a constant frequency, that resonance where the effect is drifts due to the heating, and so it's really you have to have a way to lock it in, or at least sweep in that range. So that's what we're working on. Also, we have some interest from an industry partner, and so we're going back and looking at funding sources again, and actively looking at doing something this year, depending on what's available and what the team wants to do. So the new 16 disc testing is going to start this weekend. The device is there in the lab, I believe. Jim left it there for me to put in. We're going to try to meet in the next couple of days. It's a holiday weekend, so I have more time, and I'm really excited to put that in there we need to characterize it, but also I want to get in the vacuum because the thing needs to off gas anyway. So I want to get in the vacuum as soon as possible and just run it and see what happens. So that's something that's a picture of it. And you can see here that, that's, if you look at previous pictures, which I'm not going to show one like this, but maybe I'll do that in another update. But the discs are 1 millimeter apart, and so the electrodes are closer, and there's more of them. So that's supposed to allow us to get higher energy density, and so the dPdt will be higher, and the effect should be, some power more in terms of like what it produces. Now this is having we're currently running something where the supports are only on one side in terms of like not on the active side. This was something we were testing to like get the bearings further apart to reduce the kind of things that can happen with the 2-to-1 rule and stuff like that. But we just want to get it tested. So Jim put it on a device that was put the stack on a device that was available. In addition, we are working towards, like I said, we're working towards a couple linear experiments. And as I've mentioned several times in the past, that we're on a torsion balance. And the thing about a torsion balance is that it swings back and forth. So depending on, how far the device moves, you can get maybe there's arguments that we could see mechanical artifacts happening, that it's maybe a nonlinear equilibrium, and so we get stick slip and other things. And this linear experiment, the way we're planning on putting it with these magnetic sliders, is these magnetic sliders will go in the vacuum chamber with these rails. These sliders weigh about 1 kilogram, and we're going to hang it from there. So it's just a single slider hanging, and we're going to have it at a slight elevation so that gravity slowly brings it back, right? So I don't want to put any springs on it, nothing to kind of hold it back. That's one thing with an air bearing or something like this. There's very little friction or no friction, and so it's hard to level it. And so if you're slightly off to one side, it'll kind of move on over, right? So what we'd like to do is have it so that it slowly goes to one direction, stays there, and then once it's there, we want to push it the other way, right? So that's kind of what we have in mind for the experiment. And if we can show that moving linearly, something like this, stick slip will not, because it's a magnetic bearing and there's no magnetism, pushing on anything. This is a passive magnetic bearing, or slider, I should say. And you can see that one of the things about it is that it has kind of guide bearings, roller bearings on 4 corners. That's so that because it's not the magnets could they could camber, move in that axis. So those roller bearings are there to kind of just keep it guided, so they won't add much friction, if at all. So that's what I'm excited about this, because that shows a different experiment where if we show that there's something there, and that's one of the things that the industry partner asked us for, that's really exciting and is a good proof of concept. And I'll go over this again. So this is one of the steps, is basically showing different configurations, effect, and replicating the effect. If we can do it with this experiment, I think it's a good experiment. We want to have it replicated in another lab. And actually, so we bought 2 of these sliders so that we could send it out and have a replication. So we're working towards that. And as we go down, what we're planning is that, once that's shown, we want to also have a power source and the driver included so that it all moves together. So the more things you include, the more it's going to weigh. So it's going to be harder. You really need something with low friction so that the thing still moves. So that's the tricky part. So an air bearing, but it still needs to be in the vacuum, right? So, and then down the road, something floating with the power source and the driver, and then at high altitude, something we've discussed this before, but that's still the kind of the roadmap to bringing up the TRL level. So yeah, we're still working on the actual reaction mass supports. You're still wanting to try other bearings. This is a recent run that was done before we changed out the we changed out the stack, which we still haven't done. So, but that's coming up. And this was a run where we were getting pretty good repeatability. The red is the actual torsion balance, and so and the gold is what we're getting back from the in terms of the how much energy is being put in terms of mechanical energy. So you can see when the mechanical energy is peaking, we're getting a good movement. This is another graph, and this shows the actual tracker data where you see the device moving consistently during that pulse. So we're kind of trying to narrow down the frequency for this particular device, and this is like allowing us to figure out, okay, what range we need to be in. Again, but that being said, we still need to do get a feedback mechanism. So I can show a video if I can share my screen. Let's see here. Let me share a screen. Entire screen, share. Okay. And can you guys see that? I don't know if that worked. Anyway, Tim, I don't know if the screen share worked. There we go. Okay, here's the video. This is that video. I'll mute that. A lot of static. So you can see, as per usual, we're able to get it to move. And again, the supports are on an inactive, on the brass, only on the brass. So we don't have that big stick slip motion anymore. Maybe a little bit of stick slip, but you can see it's actively pushing. So this is the video of that run. Okay. And I can stop sharing. And that's my update.
Curtis, thank you, man. Thank you very much. Okay, let me bring all the guys back in here. Okay, yeah, that is super cool. I'm glad that you guys are still getting stuff done. You're working, pushing through the nasty weather in the winter and all that kind of stuff.
Oh yeah.
Yeah.
Yeah, I have a little bit of time to take if anyone has any questions.
I wanted to bring one thing up that you were bringing up about renormalization, because I have a book called Quantum Field Theory and Critical Phenomena, 5th edition by Jean Justine, Oxford Science Publications.
Okay,
And
Andrew, I think that's for Michael. So I'm going to sign off then.
Oh, Curtis, I do have one question for you. You mentioned testing on balloons. How are the economics of that? It sounds like it would be cheaper than a CubeSat, maybe.
So if you look up JP Aerospace.
JT or JP?
JP Aerospace, and he has a YouTube channel. So you'll see what I have in mind in terms of testing, and it's nothing expensive.
Cool.
But that's like down the road. Right? That would be down the road, like a couple years down the road.
Yeah, I mean, as long as the wind is negligible at high altitude.
Yep. And actually, you this is cheap enough. You send up a control and a test.
Okay, cool. Wow.
Balloon, a test balloon, and you see if you're able.
Oh, wow, that's cool.
If we're able to push. We can keep pushing. See how fast we can get. Right.
That's really cool.
Yeah.
Nice. Yeah, that'd be the way to do it. You may want multiple controls though, because there may be like the wind is. I mean, it gets kind of nonlinear and turbulent, and things could move apart for other reasons.
Yep, it all depends on the budget, but
yeah, fair.
If you get fast enough, it becomes very obvious, right?
That's true. That's very true.
That's the trick.
Yeah.
So, all right, guys, I'm going to sign off. You guys have a great rest of your holiday weekend.
Yours is a contact letter, like no friction, so there's no friction.
Okay, thanks again, Curtis.
Mitchell, I just want to bring one thing up to you.
Sure.
I wanted to bring one thing up to you. It's called Quantum Field Theory and Critical Phenomena, 5th edition by Justine. And that the answer, what you're referring to about the approximation, is called renormalization of local polynomials S and E, large momentum explosion to S and E coefficients and CS equations. And
is it in that book?
Still very much an active area of research. And just that the book, it's, and the point of what I'm trying to tell you is that they're working on S and E. They're talking about SDE, treatment of renormalization of local polynomials, and this itself has an official orthodoxy, and it works. But the situation is, though, you're making a lot of assumptions to say about physics vacuum, about other things of sort, which may or may not be true.
Right.
And Jean Zen Justine is pretty much the Bible on this sort of thing, and he's primarily respect to QED.
Oh, it's hiding the book.
Well,
but, that's fine.
Yeah, this is the book.
Well, I don't know if it'll actually show it to us because
I don't know if you can see it, but this is the book. All right.
Yeah, the computer's taking it out on our end.
Yeah, but what I just simply am just trying to
you gave me the name of it anyway. That's fine.
Yeah, I know. But what I just am saying is that the assumptions which are used, and he's very rigorous, still making a lot of assumptions about initial conditions and initial states. And all I'm saying, especially in this area, is that people need to do some experimental foundational research, to justify all the assumptions that are put in renormalization, other things of sort.
I think we should definitely collaborate then, because we're going to be doing some experiments related to those soon, hopefully within the coming months.
Well, I think it's fascinating. What I'm saying is I think it's fascinating. And what I just am saying is that I'm very open to it. As I said, I'm an old man. I'm 70 years old, but I still think that this is absolutely fascinating. And
yeah, I mean, if we can show that renormalization implies a polarizable vacuum, that'd be like really cool.
Well, that's what I would like to do. I'm trying to understand the problem well enough so I can write something intelligent about that.
Well, we should get you in touch with David Chester, maybe. He's our resident expert here, I think, on that sort of stuff.
Okay. Well, as I said, I just am saying it because I read this book, which is pretty much the damn Bible of the subject. This is.
And they still have a bunch of open questions that haven't been tested in the lab. Yes.
That's what I'm referring to. Is that they're making a lot of assumptions. It doesn't mean the assumptions are wrong, but it's just as you need to take a look at literally everything.
Wow.
That's all I'm saying.
Well, then we should schedule a meeting with David and make a list of things, maybe even, and see how many of those we can test with our equipment.
It would be fine with me if I could do it before I die. I'm a very old man. I could die at any time. But, before I'm dead, if I could at least push people in the direction of doing that, I'd be happy as hell.
Let's do it. Let's make it happen.
All right.
I think the polarizable vacuum might be an effect happening with like in my magnet experiments, when the magnet's moving in the direction of north to south pole.
Yeah, there should be a magnet. So David and I were looking at that, and basically there's a bunch of electrostatic effects, and then there is a magnetic effect. So roughly speaking, weirdly enough, like the Bob Lazar thing. So there's a dilaton-like effect for electrostatics, and if you have two-form electrodynamics, there might be another dilaton-like connection in magnetics. And so the dilaton-like term in the electrostatics is probably related to what Drew is working on, and he can talk about that if he wants. And the dilaton-like term in the magnetic sense is what Robert's looking at, more or less. The electrostatic effect might end up being larger than the magnetic effect, or maybe we just don't know how to manipulate the magnetic effect properly. I think what's his name? Mark Sokol was doing some dynamic nuclear polarization thing, which might increase the effect of the magnetic term. So that would be very interesting. but yeah, so I mean, there's a lot of open questions still, but it's this is, I think this is going to be the year for some interesting breakthroughs.
All right, I
what
need to
you
go.
guys
I
are
need to
talking
eat.
about.
I haven't eaten all day. I'm
Yeah,
starving.
I'm kind of there too. Robert,
Yeah,
guys,
we're almost 7 hours. Jeez.
Yeah, we're at 6.5 hours, guys. You want to wrap things up for today? That's
Yeah.
okay. Yeah, Curtis had to
Thank
go.
you.
Yeah, Robert has to go. Well, guys,
Yeah.
this has been an amazing APEC. Let me apologize to you guys as well as to all the attendees in YouTube and Twitter and all the other live streams for the technical issues. I am rebuilding my studio. I know you guys have had some as well. So it's just lots and lots of little stuff, but it's nothing major. We pulled off one heck of an event, and we've got more to come. I think this 2025 is going to be bigger, better, and badder than ever. So it's going to be awesome.
All right.
Good night, Tim and everybody.
Okay. Well, guys, that's it. That's APEC for February 15th, 2025.
Well, anyway, Metro, you were quite impressive. I just wanted to say that